my primary title is Kathy's husband. All other titles are kind of negotiable. Howdy. I am from Texas, home to the most farms and ranches in the country, and we take agriculture pretty seriously at A&M. It's actually the A in A&M. The M is mechanical. I'm a professor in mechanical engineering. Retired from NASA, really proud of what we were doing at NASA. A lot of great kind of overlap with what this community needs. Actually the first project I ever did at NASA was building a robot that could take care of some plants in a chamber. And there was an astronaut in a chamber next to it that was breathing in kind of balance with the plants. So they were literally, a matter of life and death for that guy. And it really excited me to see what robotics and automation could do for plant growth on this planet. When I retired, I had built a bunch of robots, and it was a privilege to work at NASA. Incredible diversity of robots. I got to dabble, kind of. I had 500 engineers, and we were just crushing it, building all kinds of robots. And as I retired, I asked myself, what makes you happy? And I think I want to go do that. And what I decided was prototyping. I really like prototyping, and I've heard that discussed here a lot, especially with startups. And so prototyping is where you start with somebody's problem, and you think about different approaches, solutions, and you come up with a design. And then you got to rapidly build a first generation because it's probably not very good, and you want to do that quickly because you want to get on to the next one. And so you test it and you learn because it probably needs improvement. I heard some of these startup companies run Gen 5 of their machine. That's the way to do it, and if it takes years for each generation, you might not make it there. So at NASA, I had the privilege of working in a lot of different areas, prototyping. Wow, that's not what I was expecting to see there. All right. Well, I got to work on wearable robotics, lots of different machines that you could wear. See if they play that.
Shoulder being held.
All right. Well, it looks like they rearranged my slides. But at any rate, a lot of different robots. Somewhere there's a slide on all the humanoid robots. There's some free-flying robots. So in space, these would be called drones. There's no gravity, so hover is really inexpensive in space, right? So we were building robots that could pop out of the side of a spacecraft and do the inspection of the spacecraft. And ideally, they'd be cheap and disposable. You'd pop one out every time you were about to do something important and make sure there wasn't ice on the outside. That's what got the Apollo 13 astronauts. There was a big chunk of ice, and they couldn't even see it because it's hard to see yourself. So a robot that could pop out and do a selfie. We built multiple generations of that, and then we actually took that technology offshore and built a CCAM version of the air cams. See if we can find rovers. I'm now working with the Army, and they're confused because I keep calling their trucks rovers, but ground vehicles that are robotic are important to me, and I got to really work with a lot of different ones at NASA. I heard in the previous panel discussion of trafficability. Some of the earliest work in trafficability, creating the industry of terramechanics, was funded by NASA for the Apollo rover, and that's figuring out basically how not to get stuck. And then if beyond not get stuck, it's how to get some jobs done. But again, don't get stuck. And so we built a number of machines, and I think I saw a video of one of them flash by. I also got to work on a number of humanoids. Here's 3 different generations of humanoids, and these are very high-end. These are like $5 million a copy for each of these robots. So these, especially back in the day, would only be relevant in a super expensive application, like a $100 billion space station, where one of these might actually earn its keep. But now as the technology has advanced, companies in the US are targeting a $50,000 humanoid as a price point. And at $50,000, there are a lot of applications that actually make sense. And the shocker this last year was China, a Chinese company called Unitree, is now selling a $6,000 humanoid. At that price, they're down into a series of applications that are just all around us. And so as the price point comes down and the capability goes up, at some point you cross that price point, kind of like when the average person could afford to buy a Model T. And when you cross that price point, something pretty significant can happen. So I think that's where we are right now in humanoids. So with the opportunity to build, humanoids and mobile robots and wearable robots and flying robots, I decided that being a manager, it had been fun. But maybe I'd like to go back and get to be an engineer again. So I retired and I came to Texas A&M. So let's see if I can get to the A&M robots. And I just got busy. So what we did, the very first thing was a robot that I developed at NASA like 20 years earlier, and I kind of stuck a pin in it and said, I'm going to come back to that robot someday. And it's a ball, and it's basically indestructible. What I wanted to do with it was be able to drive down into a crater on the moon where people are really not going to be allowed to go. The craters on the south pole of the moon are minus 380 Fahrenheit, which I think even for North Dakota, just check me, that's still cold, right? Minus 380, that's chilly. We're not, and they're huge. They're like 20 miles across in diameter and miles deep. So what could get to the bottom of a 2-mile deep crater? Well, a ball's going to do pretty well. So the Robo-Ball, the first one we built in 2003, did quite well. When I got to A&M, I brought a bunch of students together. Look at these guys, they're awesome. And they very quickly built Robo-Ball 2 and then Robo-Ball 3. And we now just picked up an Army project. Turns out they also can, guess what, drive on water. In fact, they're quite good driving on water. So we're now looking at Army applications for being able to drive on and off beaches. And most robots should go nowhere near a beach. You hit a surf line with salt water and sand. Even the sand itself gets fluidized, and every weekend the Gulf of Mexico eats some guy's pickup truck. He parked it too close to the beach, and these balls can just drive right in and out of the surf, and they're pretty amazing. Let's see if we can advance. Another problem the Army had was they would show up somewhere and they'd have to try and get a robot out and deploy it, and they'd open the hatch and they'd all bail out and they'd get the robot out. And we gave them an armored truck for a reason. And why are they getting out of their truck? Well, it's because they're deploying the robot, and that's just terrible. So we built a deployer system that could mount on any truck, and we could deploy a robot in 15 seconds. Just push a button, the thing opens up, and the robot comes out. We also made some inserts so we could adapt that to handle all kinds of robots. So these little tank robots, quadrupeds, a couple different brands of quadrupeds, drones, and even humanoids. And sure enough, a 2-foot ball fits in it quite nicely. We even deployed without stopping. So a couple of these robots, like this little tank robot, we were able to deploy at about 5 or 10 miles an hour. And I wouldn't do that with one of the dogs. It might break a leg, but and then if the mission went well, you're going to go recover your robot, And at that point, we decided we could take a little extra time. So it takes about 30 seconds to recover a robot. But that means that soldiers don't have to be getting in and out of their truck to go, futz around with the robot. In fact, at that point, you don't even need people in the truck. And so that's really where we're getting to something important. Let's see. Back up here. Of all those rovers that I built at NASA, my students have now built a mini version. And it turns out, at NASA we don't publish a lot, so all the algorithms that we develop for using the active suspension and the point turning, we never really published any of that. So my students are now going back through all those algorithms and developing them to make sure that they can be parameterized at different scales and different geometries. And again, a great team of young people who are just crushing it. And then the last one of these robots I want to tell you about is a space simulator. This can simulate 2 different spacecraft interacting with one another. And I'm doing that with Space Force for a robot to go basically be a tow truck and to go pick up another spacecraft and move it around and refuel it. So these Stewart platforms allow me to simulate 2 spacecraft in space, in frictionless space where they're just floating. We are also building an awesome new facility down on NASA property This is the Texas A&M Space Institute. It will have a 2.5-acre indoor moonscape and a 2.5-acre indoor Marsscape. And so, because they're air-conditioned, climate-controlled, they'll be a really good place to test mobile robots. So we're going to have opening day in about 13 months, end of September 2026. And I would love to have some of my new friends from North Dakota bring a robot to come see us there. I mentioned Space Force. I am running an institute. I've got 7 other universities that are part of it. I'm always looking for new partners. So if there's any faculty here who would like to be involved in that, please catch me, and I'd be happy to talk to you about it. So I'll sum up by saying that if you need a better mousetrap, give me a call. I'd love to put some young people onto the problem that you've got, come up with a quick prototype, and maybe rinse and repeat a few times and get your problem solved. With that, thank you very much.
Thank you so much, Robert. Hey, Robert, real quick. So over the last 3 or 4 years, we've hosted a space agriculture conference. Maybe just, can you just proselytize for a couple of minutes about what you think is going to be happening as we get onto the moon, Mars, and how we're going to feed these people?
Absolutely. You know, here's a dumb idea. Let's ship dirt to the moon. That's a dumb idea, right? So that first project I worked on, the robot that was tending the crops were all in trays, and the trays were a hydroponic mix that used a basalt that's kind of an igneous rock that's common on the moon. You know, anybody here a potato farmer? You know, certain crops grow really well in volcanic soils, and coming up with that hydroponic mix made a lot of sense. So when you're going to colonize some place, at some point you've got to start living off the land. And it's easy on Earth because wherever you go, there's oxygen and water, and you know, when my relatives immigrated here, they came into the Dakotas in the 1880s. They were mostly carpenters, and they were kind of bummed they couldn't find as many trees as they were used to. But nonetheless, there were resources they could use to build a house and get going. On the moon, it's pretty barren. So the materials that are there are going to it's just going to take more work to extract the water, to be able to make concrete using that material. But that's what it's going to take. We have the technology to do it. It's really just a matter of who and when. There's you said proselytize? Okay, so the rumor has been that the Earth's first trillionaire is going to be whoever figures out how to exploit the resources of the moon. Now, I'm hearing that we might have some homegrown trillionaires here coming up, but I think a few of them are involved in the space industry. And that's because the moon's got a lot of resources. And you know, North Dakota, the economic report you heard earlier was about your resources. You know, you've got good resources in North Dakota. We do in Texas. And so I think using robotics and automation to mine and extract and eventually grow food on the moon, you know, that's going to happen, and it's just a matter of who does it and when they do it.